Lakshmi?
Shall we start, sir? We are live on YouTube, actually.
Yeah. Let's not wait. We'll start on time.
Okay, sir. Good evening, everybody. On behalf of Team IAP CCB 2026, we are very happy to welcome you to the session 5 on RAPP. So, research assistants for pediatric postgraduates and practitioners. We welcome all the attendees today. We welcome our mentor and chief advisor, Nedunjeliyan sir. We welcome our president, Sudhakar sir. We welcome the convener of RAPP, Sridevi ma'am. And of course, today's speaker, Dr. Hemchand, who has kindly consented to speak on sample size calculation. So in research, bigger is not always better. The right size is actually essential. And sample size is where statistical precision meets scientific purpose. So this is what we are going to talk about today. May I request our president, Sudhakar sir, to offer his introductory remarks, following which Sridevi ma'am will take over the proceedings. Thank you.
Good evening to all. I'm very happy to introduce our speaker, Dr. Hemchand Krishna Prasad, a senior consultant pediatric endocrinologist from Mehta's Children's Hospital. I'm really proud and happy to introduce Hemchand, who was my student, a very brilliant student and a committed person. Even during student period itself, he used to be very much interested in research, and I often see him discussing with Dr. Sarada Suresh Madam, who was our mentor for all of us actually. Madam is the pioneer in research, like Dr. Nedunjeliyan said. I'm really happy to have my student now as a faculty, going to teach the students about sample size calculation. Welcome, Dr. Hemchand. And thank you, Dr. Sridevi. This is the convener for the Research Assistants for Postgraduate and Practitioner RAPP program. Thank you, Nedunjeliyan sir, for guiding us all. Thank you, Dr. Tambarasi, who is liaising everything. Thank you.
Thank you, Sudhakar ji. Good evening, all. So, welcome you all to the 5th session of our RAPP program, Research Assistants for Pediatric Postgraduates and Practitioners. So, it is a humble attempt by IAPCCB to present to you a dry and a challenging topic of research in an interesting way and in capsule form. So, whatever we are presenting is a primer on the topic, and further learning is definitely required to master the topic. But whatever is being presented will be the curtain raiser on that topic. So we saw in our series first how to choose a research topic, then how to search the literature, then we saw about the framework of research, then we saw about the study designs. So now, after choosing the appropriate study design, framing our objectives, choosing the study design, the next bottleneck will be the sample size calculation. So today we have none other than a renowned teacher, Hemchand, who's with us. He is going to take you through the importance and how to calculate the sample size. So without wasting much time, I just hand over the forum to him for him to take over and present to you on this. Over to Hemchand.
Thank you, ma'am. Thank you, sir. Thank you, everybody, for this nice invitation. I hope the slides are visible and I'm audible.
Yes, Hemchand.
Yes, thank you, sir. So I think sample size estimation, it's a topic which really taught me a lot as I prepared through. And sample size estimation is very important for a postgraduate researcher at the beginning, because the choice here is whether you are going to cut your fingers for the glove, or are you going to adjust the glove size for your finger? Are you going to cut your fingers for the shoe size you have bought, or are you going to alter your shoe size for your foot? Are you going to cut your body for the shirt size, or are you going to choose a different shirt size? Choice of sample size is as important as that. Over the next 20 minutes, we will try to understand, number one, what is sample size, why it is important, the points to be borne in sample size calculation, the steps, some practical examples, and how to tweak it in various situations. Number one, what is sample size estimation? I think sample size estimation has a lot of importance in various settings. An opinion poll is taken of a small sample to ascertain who is likely to be the next chief minister. A government samples a small sector of the population to see if the scheme it is offering is really beneficiary, reaching the beneficiary. Similarly, medical people research on an optimal sample size, which is chosen from the target population based on specific inclusion and exclusion criteria, which is expected to represent the population in itself. So sample size, the sample is a segment of the population which is likely to represent the actual target population. Why is sample size calculation important? Sample size calculation is important for number one, the scientific validity of the study. The observations you make in your study and you convey to the public, is it relevant scientifically? Does it have a scientific validity? When you conduct some statistical tests, is it meaningful? Whether the results you observe, is it optimum? And sample size calculation from a practical perspective is very important whenever you present it in the IEC, the Scientific Research Committee, and lot of journal editors now reserve their right to question the sample size calculation as well. If the sample is too small, the study is underpowered, wasteful efforts, you are missing a marginal difference. Whereas if you conduct it on a larger sample size than it is needed, you're wasting resources, it is difficult to execute, and it is unethical. So an ideal sample size is one which is neither too big, not too small, and it caters to the needs of the research question and the study design. So what are the points that have to be borne in sample size calculation? Let us go through one. We've understood what is sample size and why it is important. What should we know before we go embark upon sample size calculation? The first and the most important thing is the level of confidence. So generally, what do you mean by level of confidence? The level of confidence is the fact that if a study is repeated multiple number of times, the 95% confidence interval would contain the true population value as shown in the slide. If you do it multiple times, the same study is repeated, the results would lie within the 95% confidence interval and 5% chance of it exceeding a tolerable permissible level. So this is usually taken as a level of confidence. If you go in for a higher level of confidence, so that it never goes out of the pre-specified tolerable value, the sample size is going to increase. And for convenience sake, if you reduce a 95% confidence interval, then you're probably going to reduce the sample size. So an optimally chosen confidence interval, usually conventionally taken as 95%, is important to arrive at a proper sample size. Type 1 error. Type 1 error, as shown in the slide, is nothing but a false positive error. The probability of falsely rejecting a true null hypothesis. This is a sheep hidden in a wolf's clothing. Probability of finding the difference between two groups when it does not exist. Conventionally, it is taken at 5%. If you set a lower type 1 error, the larger would be the sample size. So this is the second determinant of sample size. Type 2 error, failing to reject a false null hypothesis. A wolf hidden in a sheep's clothing. Probability of not finding a difference between two groups when it actually exists. I repeat, the probability of not finding a difference between two groups when it actually exists. The value of beta is conventionally set at 20%, and 1 minus beta is considered the power of the study. So this is the third parameter. So lower the beta value, higher the power, larger would be the sample size. So if you want to have a higher powered study, you would need a larger sample size. The fourth important effect is the degree of precision. How close is the estimate to the true value? Greater is the precision needed, greater would be the sample size. Lesser would be the precision needed, lesser would be the sample size. The precision would be decided based on the consequences of a wrong precision. If it's a behavioral study, you're just trying to study the natural course of the disease, a diagnostic test, lesser precision may be acceptable. But if you're studying mortality, suicide rate, then a higher precision would be required. And again, madam wanted me to highlight this. Whenever a researcher gives the value of precision, you look at whether it is absolute precision or relative precision. For example, if you're looking for the proportion of hypothyroidism in childhood obesity, which is really about 50%, you're looking for a brick in a haystack. You're more likely to find the answer. So a sample with an absolute precision of 5% will detect between 0.45 and 0.55. However, when you're looking for a needle in a haystack, like a rare disease like Cushing's in childhood obesity, you go in for relative precision. That is 5% of the prevalence. So here you're looking at 5% of 0.06. So the sample will detect from 0.055 to 0.065. So when you're looking at relatively more common conditions, you go in for absolute precision. When you're looking for relatively rarer conditions, you go in for relative precision. The fifth important determinant is a sample variation. When you do a literature search and you find the proportion of subjects with a characteristic of interest is small in a previous study or a pilot study, the sample is large. If the proportion of subjects with a character of interest is large, then the sample is small. Suppose you're studying obesity and you find the prevalence of hypertension is just 10%, then the sample is large. However, if you find 50% have hypertension, then the sample to study this would be smaller. Similarly, looking at the variability, suppose the outcome interest you're looking at is mean and standard deviation. And the standard deviation is high. Suppose the mean blood pressure in the study group is 100 plus or minus 20. So you're looking at a large variability of 20. So the sample size would be larger to attain. However, if you're looking at a mean blood pressure of 100 plus or minus 5, the variability is small, the standard deviation is small. So the sample required would also be consecutively small. So these are important determinants of sample size. And very importantly, the effect size. What do you mean by effect size? Effect size is the smallest difference that is clinically meaningful. I repeat, the smallest difference that is clinically meaningful. Suppose you are looking at the impact of a drug on blood pressure in obese children. Suppose drug A causes a reduction of 2 millimeters of mercury, drug B causes a reduction of 8 millimeters of mercury. At what level of reduction of millimeters of mercury would you consider this as significant? So the smaller is the effect, larger would be the sample size. Larger will be the effect, smaller would be the sample size. So this decision is made by the primary investigator. What is going to be the effect size he is going to specify in the study based on his personal experience or previous literature research. And if you're looking at interventional studies like randomized clinical trials, clinically meaningful outcome measures like mortality, reduction in blood pressure, reduction in waist circumference, reduction in BMI, etc., which is derived based on previous meta-analysis or personal experience, is also a very important measure which the researcher should specify while calculating the sample size. So if you want a smaller chance of type 1 error, if you want less likelihood of rejecting a true null hypothesis, you need a larger sample. If you want higher power, you need a larger size. If you want a smaller effect to be detected, you need a larger sample size. If you want a larger effect to be detected, you need a smaller sample size. If you have a higher variability, standard deviation, you need a larger sample size. If you have a smaller proportion of the incidence in the disease, you need a larger sample size. Higher anticipated non-response, you require a larger sample size, and more the subgroups, you need more the sample size. So vice versa for smaller sample size. So these are some of the important determinants of sample size, which a researcher should know while doing the sample size calculation. Coming to the fourth important question. So we understood what is sample size, why it is important, what are the parameters a researcher should know to understand and calculate sample size. The fourth question is, what are the steps in sample size calculation? Question number one, it's like climbing a ladder to reach a bottle of gold, which is the sample size. Step number one, a crisp research question. Step number two, a primary outcome that aligns with the research question and the type of the study. Step number three, an extensive review of literature to find out from a previous study to find out the important parameters that would be required which matches the current study. Step number 4, from that study, you retrieve the data pertaining to the sample variation, effect size, and all the parameters that were discussed previously. And number 5, make finer adjustment and ultimately reach the pot of gold, which is a sample size. Sample size calculation in these steps always involves Gaussian distribution and simple random sampling. If it is non-Gaussian or if it's a different method of sampling, a different approach would be required. So these are the important steps in sample size calculation. So let us try to apply these steps in some of the hypothetical situation. So situation number 1. A researcher works in an obesity clinic and tries to decide his thesis topic. The first question that comes to his mind is, what is the prevalence of metabolic syndrome in adolescent obesity? So he has identified the research question. What is the type of study? It is the cross-sectional observational study. And what is the outcome measures? It is the prevalence of metabolic syndrome. Step number 3, he does an extensive literature search, and a previous study has reported a prevalence between 0.26 to 0.29, that is 26 to 29%. And the precision for this particular study, he sets it at 5%, which is a convention. You're not looking at a grave condition to set a very high precision. So you set a 5% precision. And he gives the necessary information. He gives a standard normal deviate, which is 9.65. The expected prevalence, which is there from the previous study. The precision is there, which is specified at 0.05. And the formula is shown in this table in the top right corner. The parameters are filled there and the sample size is arrived at. And the sample size is kind of adjusted for attrition, incomplete records. A 10% increase is made and a final sample of around 296 is arrived at. So the 5 steps: framing the research question, type of study, doing a proper literature search, selecting the parameters to be provided, and adjusting in the final calculation after calculation based on a standard formula. So this is the first example. The second research question which he wants to do is, can waist height ratio, a simple diagnostic test, be used as a screening tool for cardiometabolic risk? This is the second type. So this is a diagnostic test validation study. So for this, he does an extensive review of literature, and he observes that in a previous study, a waist height ratio of 0.67 was able to identify with a sensitivity of 95% and a specificity of 87%. So he uses that study to calculate the sample size. He selects the parameters, which is a Z value, the sensitivity from the previous study, the specificity from the previous study, the precision, which he sets at 5%, and the baseline prevalence, which he has again attained from the review of literature, which is 8%. All these values are fitted into the sensitivity and specificity formula, and a calculated sample size is arrived at. Both of them have slightly different values. The final one is chosen based on the larger sample size. So you want to apply both sensitivity and specificity in the new diagnostic test, which is waist height ratio. So the sample size is arrived based on this calculation at 1000. So this is a second situation where the researcher uses a sample size calculation for a diagnostic test. So the concept remains the same: framing the research question, the type of the study, literature search, choosing the parameters from the literature search, applying it on the formula, and calculating. Now the third question: what is the relative risk of grade 3 fatty liver with increasing BMI? So this is a cohort study. So he does step 3, he does an extensive review of literature. He observes that the expected relative risk is 5 to 10. Expected relative risk is 5 to 10, and the proportion of non-obese with the exposure is 0.0005, that is 0.5 to 1%. So the parameters that would be needed would be, what is the previous study relative risk? What is the proportion of non-obese with fatty liver? What is the type 1 error rate? 0.05, we learned by convention. What is the precision? And what is the ratio of cases and controls? So in this study, the researcher decides to set the ratio of cases and controls as 1:1. So all these parameters he has arrived based on his experience and from the previous study. He puts it into the formula, which is shown there. the relative risk, the proportion in the non-obese group, and the Z values, and he arrives that the sample size is nearly 490 in the obese group and 490 in the non-obese group. So the concept remains the same. In a type of study, cohort study, you look at the relative risk, the proportion in the non-exposed, non-obese group, the ratio of cases and controls, type 1 error rate, type 2 error rate, and all these values are fitted in, and the final sample size is arrived at. Let's go to the fourth scenario. What is the association between birth weight and adult risk of obesity? So this is a case control study. So a review of literature is done, and a previous study has reported the mean birth weight in obese is 3,000. The mean birth weight in non-obese is 3,250. So the pooled standard deviation based on the study shows is 1,000 grams. So the parameters to provide would be the ratio of cases and controls 1:1. Pool standard deviation is 1,000 gram, and the type 1 error rate alpha is usually specified at 5%, type 2 error rate 0.2, and the power of the study is 80%. So these values are fitted into the formula that is provided. R is the ratio of cases and control, D is the precision, the pool standard deviation as shown in the slide, and this is calculated. And this calculated value arrives as 250 in each group. So I hope the concept is clear. The same 5-step approach: a research question, the type of study, outcome measure aligned with the primary objective, review of literature, collect the parameters, put it in the right formula, adjust if needed, and arrive at the proper sample size. This is another study. What is the risk of obesity with increasing screen time? This is a case control study. More the children are exposed to screen time, more is the likelihood of obesity. So here you do a review of literature, and case control study, as discussed in the previous sessions, you look at odds ratio. The odds ratio of adolescent obesity and screen time is 1.5, and the proportion of non-obese with screen time is 0.33. So the parameters to be provided in this formula includes ratio of cases and controls 1:2, the proportion in the non-obese group 0.33, odds ratio 1.5, 5% type 1 error, and your power of the study 80%. So these values are fitted into the formula, and adjustment is needed. If you're having more than one risk factors, then you calculate for each of the risk factors and choose which gives the maximum sample size. Lowers the odds ratio, higher would be the sample size. So in this particular scenario, 612 cases are arrived at, and 612 controls are arrived at. The 5-step approach: research question, type of study, you do a literature search and arrive and collect the necessary parameters, fit it into the formula, and adjust. This is another research question where you're looking at the impact of BMI Z-score reduction with semaglutide versus lifestyle modification. This is a randomized clinical trial. So you're looking at a specific outcome, which is a reduction in the BMI SDS. A literature search was done. Here, the expected mean difference in the BMI was 0.25, and the pooled standard deviation was 0.7. And here RCT comes the meaningful and achievable clinical difference. A 0.45 reduction in the BMI, 0.4 to 0.5 units reduction in the BMI is considered clinically and meaningfully achievable. So this is something the clinician would have to decide based on literature search and personal experience. If I'm a stringent researcher, I would say a BMI reduction of 0.8 would be clinically achievable and meaningful. If I'm a lenient one, I would say 0.3 is achievable and meaningful. And ratio of cases and controls, and you fit the power, because here you're looking at a randomized clinical trial. So you set in a higher power and a type 1 alpha error of 0.05. It is fitted into the formula, and adjustment is done for the dropout, and you find the number of cases are 76 and the number of controls are 38. Total recruits are 114. 5-step approach: research question, type of study, review of literature, choose the outcome measures, fit it into the formula, and arrive at the optimal sample size after adjustment. This is a last scenario. We are looking at a new drug, whether it can be used in adolescents with obesity. There is no previous precedence of this study. It's a pilot study. It's a new study. It's a new drug. Here you go in for a pilot study. This remember, you here you have to apply a practical, a typical pilot size is around 12 to 30, which is often distributed across the weight trials. Here you have to remember that this will not satisfy the necessary statistical modules, but this will form a basis for a more powered study in the future. When you're looking at smaller than desired sample, you'll always remember that a small scale study is better than no study at all, and it might not give accurate conclusive results, and you might have to use different statistical tests. Now you understood what is sample size, why it is important, what are the concepts involved, what are the steps, and we applied it in some cases. Now, is it always so complicated? Is it always that you have to use such complicated formula? No. You can always take the help of multiple online platforms, applications that are available, which are summarized in this slide, and many of them are free, many of them are paid. There may be minor variations in the sample size provided, but they are good enough to help you to calculate the sample size. And there are normograms that are available that help you if you don't have access to online platforms based on the set level of significance and allowable difference. You have used these normograms for calculating TRP in hypophosphatemic rickets. Similarly, you use these normograms to arrive at the optimal sample size based on the allowable difference, the level of significance, and the precision. Remember, if you're not able to do sample size calculation for various logistic reasons, you might have to use some thumb rules. If you're looking at a large size medical trial, it's about 300, mid size 100 in each group, small size is 30. And these can be used where the resources are limited. And if you're looking at a prospective study, you should have at least 30 persons with a finally available outcome in each group. And if you're looking at establishment of normal values in healthy subjects, at least 200. So these are thumb rules which might not stand the test of statistical scientific basis and statistical significance, but are taken in practical consideration. And the last question, how to tweak sample size. Always inflate after calculating sample size, inflate it for measures of uncertainty from the previous study, inflate it for data pertaining to missing data, incomplete data, lost to follow-up, etc. You might alter the power to alter the sample size. You might adjust for covariates like comorbidity, severity, etc. You might have to adjust for the sampling technique. And if you're doing more complex analysis like multivariate analysis, subgroup analysis, you might need more sample. And if you have a very small sample, you might have to go in for non-parametric tests. To sum up this short presentation, to calculate sample size, always remember calculation of sample size is very important. It depends on the primary outcome measure and the study primary objective. You have to understand the feasibility of the sample in your setting. You have to do a proper literature search based on the study design, and you have to collect the parameters that have to be provided for sample calculation with expert inputs from a biostatisticians and help from online platform tools. And this final sample size can be tweaked based on various parameters like dropouts, attrition, and a final sample size is arrived at. Thank you very much for your patient hearing. Thank you, sir and ma'am, for this nice opportunity.
Thank you, Hemchand. Very well presented. It was crystal clear. I would just like to add by summing up that sample size calculation is as simple as 1, 2, 3. Step 1 is choose a good sample size calculator. Like you have the online calculators, you have the softwares, you have the mobile applications. Commonly used softwares are OpenAPI and GPower, which are free softwares which can be used. So that is step 1. So you decide on your calculator. Step 2, you find out, you decide what is your primary objective and what is your study design. That is, you are going to compare means, you are going to compare proportions, you are going to find out sensitivity, you are going to do a prevalence study, estimate a proportion. So what is your objective? So that is the second thing you need to do. Third thing is, that will choose the appropriate formula. The second thing will lead you to the appropriate formula which is required. So third thing is you just have to do a good literature search, get a good study which was done with the same primary objective as yours, and then take the results of that study and feed into the formula, and you will get the sample size. So it is as simple as 1, 2, 3. So thank you, Hemchand, for your wonderful presentation. Now over to our mentor, Nedanjalian sir, for his concluding remarks.
Yes, madam. Good evening to you all. So, as I used to tell as a science students, we are worried about these numbers. We have numerophobia. So you need not be bothered about much about these formulas as well as numbers. Maybe once you have decided, you are actually able to do the calculation and other things, you can go ahead. But the only thing is we need to have all the data as desired for that particular formula which we are using. First of all, we should know what is the situation, whether we are interested in actually finding out the outcome of mean or proportion. This is very simple. The other one are maybe simple descriptive study or analytical, where as Hamchand has pointed out, as usual, he has done excellently well. He made a very difficult topic, the simple one with actually all the examples possible. As he has pointed out, if it is going to be a case control analysis, maybe we need to say first owners, cases, and controls. 1:2 or 1:3, whatever this we need to actually decide. Then what is that exposure factor we are looking for among the cases and controls? Like that, it will actually vary. For the prevalence of our this one study, we need to tell how large is the population from where we are actually going to select the study, and what is the prevalence or incidence expected from the previous study or pilot study. And we need to tell to the statistician, or maybe we need to choose and apply in our this one software. That is what is the degree of precision. It has actually been elaborately done by the our actually faculty now today, whether it is absolute or relative precision. That these are all the things needed. So it is not a magic number. We need to actually have some actually data which need to be from the literature, or it may be from the pilot study or your own experience, whatever it is. Then actually we need to know from the study design and objective what are all the data to be applied and which formula to be selected. And while doing so, we need to actually look into the thing whether we are actually applying the correct formula for the correct hypothesis. That is important, right? And the other one is, as he has actually pointed out, the formula is the software also, it is actually formula based. That we need not do the calculation. It actually with the factors, whatever it requires, we actually enter, just going to actually go through the formula and give us the results in no time. That is the way. So the sample size can be done in manually by calculating the formula, or through the software. As I told you, even software applies the formula which is actually usually given in the initial state, what formula is used. And the third one is, as he has pointed out, some tables are this one nomograms available. Everything is not possible, as he has pointed out some situations where it may not be possible even to do pilot study. We need to have some rules. The only thing is you should not actually go with the idea for all type of studies 30 is the large sample size. It's because we consider for calculation of sample size applying statistical significance that 30 as the adequate sample size. We need to have the outcome of interest in the population script that 30%. So to it may be 1,000, it may be 100 required to actually show that pick up that 30 outcome. If the outcome is going to be larger, the small size sample size will be smaller. If it is going to be very meager, suppose that instead of 30, if it is going to be 0.3%, To pick up that 0.3%, we need to go in for larger sample size. That's all. Other things he has actually nicely done it within a short time. And other thing, when after this one, he told some adjustment and other things. The dropout is the first thing we need to remember. And the dropout for that matter, it should not actually exceed 20%. If it exists, there are different type of analysis, especially in comparative studies and the other thing. And one other thing, what we will be doing for primary objective, which usually will be on proportional morbidity, that is prevalence or incidence of particular condition in the hospital population or among the patients attending a special clinic. So we would have actually calculated that will be in a larger number. To pick up that, maybe the sample size needed will be smaller. Then we will go for some subgroup analysis after actually completing the study when we start putting the table. At the time, maybe we may not be able to have enough sample size to have a subgroup analysis or stratification done. So before actually starting the study itself, we should actually sit and decide by yourself. You are very confident about deciding the sample size or discuss with the biostatistician all these things and actually set right. Because as he told, maybe this is for Gaussian distribution with the simple random sampling. If other sample size like cluster and other sample size sampling technique applied, the sample size will increase accordingly. So that also we should remember. That is the adjustment as a fifth step he was actually repeatedly mentioning. It's nicely done, Hamson. Congratulations. I hope I have justified in bringing out a little more points and summing up. Thank you very much for the opportunity.
Thank you, sir.
Awesome. Lakshmi, can we
Over to
conclude?
Tambarasi.
Tambarasi.
Yes, ma'am. Good evening, sir.
Good
Can you hear me? Good evening, sir. On behalf of IIT CCB, I would like to thank our guide, Dr. Nedillian, sir, and convener, Dr. Sridevi ma'am, for their continuous support and guidance. A special mention to Hemchand, sir. It was really a good presentation, sir. As Nedu sir said, we are always worried about and we are scared about numbers. You made us to understand the topic very easily with that 5-step approach. It was a good learning point today we had. So hope PGs also would have got a good learning point today. On behalf of IAP, we would like to thank you for the wonderful presentation. Thank you, sir.
Thank you, Ma. Good night.
Thanks to
Thank you.
everybody who joined us
Thank you,
today.
everybody. Thank you, everybody.
Thank you all.
This session has been live streamed on YouTube. All the other previous sessions are available too. So you may subscribe to our YouTube channel. Until we meet next time, good night from Team IAP CCB 2026. Thank you.
Thank you.
Good night. Good night to all of you. Good night. Lakshmi?
Yes, sir. Yes.
Lakshmi, can we send the YouTube link in the connecting buds about the RAPP program?
Oh, yes, sir. We will share it, sir. We will share it.
All the
Yes.
5
All can be shared. Yes.
all the 5 sessions we can share.
Yes, yes. I'll share it.
Okay.